Discussion for lesson 3, which is properties of solid. So we already done discussing all of the lessons pertaining to preliminary stage. So now let's go to the quarterly lesson that we will be discussing, that will serve as your coverage for this examination, or for tomorrow's examination. So first is the properties of solid. So this will serve as a review for you, because I assume that you already know this one, because in general chemistry, properties of solid or properties of metals are already been discussed. So I assume that you've already know this one. So for this one, I will give you a review for the different part or types of properties of solid. So let's start with the electrical and thermal conductivity. Sorry for my voice, because I think medyo paos ako. So just bear with me with the discussion. So first, again, the first properties of solid is electrical and thermal conductivity. So of course, if there is so-called electrical and thermal conductivity, those solids are capable, our wires are made of wires, and it is basically a metals. So probably if if that certain solid has a property of metal, meaning to say there is so-called electrical or thermal conductivity that being produced. So one of the solid that is include in metal are the copper, because generally when copper is a type of a metal that produces a good electrical conductivity. So that is why properties of solid is one of the properties of solid is electrical and thermal conductivity. Next to that is we also have a malleability and ductility. This is very very known with regards to the different metals in the different metals pertaining to a solid, kasi you've already know what is malleable, or what is a what they call this, a certain substance that is ductile. So malleability describes the ability to hammer a solid into a sheet. So meaning to say, malleability is the one that has that is capable to hammer a certain solid into a sheet form without breaking it. So aside from malleability, we also have ductility. When we say ductility, it refers to whether a solid can be stretched to form a wire. So that is also a properties of a solid. Next would be melting point. Melting point is very what do you call this, very some point used in melting a certain solid. So that's why it is involved in the properties of solid. So breaking the weak intermolecular forces, these are the forces between different molecules, of course, not the strong covalent bonds that hold the individual molecules together. So as a compound like sugar can be easily melted on your stove top. So that explains why a certain solid can be melt by the process of a melting point. So next properties would be solubility. So solubility, it is the extent to which a solid is dissolved in a particular solvent. It is called solubility. So solid can be dissolved into a variety of types of solvent, but for now we will focus on solubility in water. Dissolving a solid requires, so meaning to say, a solubility has a process which is divided into a solvent and solute. As we all know, solvent is the one that is the substance that na nagdi-dissolve sa isang substance. So yung nadi-dissolve, yun yung solute, right? Yung solvent, siya yung nagdi-dissolve. I've already discussed that one. So that will what do you call this? That will give an explanation with the process which is solubility. So lastly, we have density. Density defined as the amount of mass exists in a certain volume. So density has its own formula. So we've already know what is the formula of density. So it is actually defined from the amount of a mass and that exists in the amount of a certain volume. So that was the properties of solid. So always remember that it starts with electrical and thermal conductivity, malleability and ductility, melting point, solubility, and density. So now let's proceed on the phases or changes or diagrams of water and carbon dioxide. Fusion, evaporation, and sublimation are endothermic process, whereas freezing, Condensation and deposition are exothermic process. So what is the differences between endo and exothermic? So basically, when we say exothermic process or exothermic processes, it is one that gives off heat. This heat is transferred to surrounding. While when we say an endothermic processes, it is one in which heat has to be supplied to the system from the surroundings. Okay, take note everyone, huh? When we say exothermic processes, it is one that gives off heat, meaning to say the heat will transfer to the surroundings. While when we say endothermic, it's a process which heat has to be supplied to the system of from the surroundings. So what do you think, or how do you know if it is endothermic or exothermic? So basically, we can eventually know that if the methods, or we can eventually distinguish the methods between the exothermic and endothermic reaction when the energy is released in an exothermic reaction. The temperature of the reaction mixture increases. Okay, always remember that one, huh? When the energy release exothermic reaction, the temperature of the reaction will increase. While in the endothermic, when the energy is absorbed, the endothermic reaction, the temperature will be decreasing. Okay? Exothermic release, endothermic absorb, then exothermic it will release increases, endothermic it will absorb decreases. Okay, so much for that. So let me read this one. The statements: changes of state are example phase changes or phase transition. Yes, of course, that is very understandable. All phase changes are accompanied by changes in the energy of a system. Changes from the more ordered state to less ordered state, such as liquid to a gas, or endothermic. Yan ang nga sinasabi ko, that endothermic is when the energy will absorb, then eventually the temperature will decreases. So meaning to say, for example, liquid to gas, that is an example of an endothermic processes. Changes from a less ordered state to a more ordered state, such as liquid to solid. So it explains the releasing of the exothermic reaction, and the reaction will be the mixture will be increase, and that is a good example of an exothermic reaction. Okay, so let's go on to the energy changes accompanying phase changes. So there are a lot following changes when an energy accompanying a phase changes. So it requires a phase changes requires energy. Yes, of course. Yes, because in releasing an energy, there is so-called a changes. So a changes will occur if it will release, or if will require a certain energy. A phase also will change if either it is less order state requires energy, of course, again. Then melting process of a solid called fusion. So what do you call this so-called fusion? So meaning to say, if a solid will melt, that is called as a process which is fusion. Heat of vaporization, heat needed for vaporization of liquid. Melting, vaporization, and sublimation are endothermic. Freezing, condensation, and deposition are exothermic. This is actually eventually explains the summarization on how can you differentiate exothermic and endothermic. So now let's discuss also the heating curves. So how can we know the curves of a certain heat? So heating curves, it is a graph of temperature of system versus the amount of heat added. So it is used to calculate enthalpy change. So when we say process which is called as enthalpy change, it is approximately defined as equal to the differences between the energy used to break bonds in a chemical reaction and the energy gained by the formation of new chemical bonds in a reaction. It describes the energy change of a system at constant pressure. So that explain what is enthalpy changes. Remember, again, it is approximately equal to the differences between the energy used to break bonds in a chemical reaction and the energy gained by the formation of new chemical bonds in the reaction. It is a good description that the energy change of a system will be constant pressure if it is in the enthalpy change. Okay? So we will be undergoing also with the changes, or will the with the calculation pertaining with this process. So along the way, along the discussion, we will be knowing the calculation, or how can we calculate a certain enthalpy change. Super cold water, when water is cold to a temperature below 0 degrees Celsius. So that is basically constant one. So critical temperature and pressure. Critical temperature, it is defined as the highest temperature at which a substance can exist as a liquid, while critical pressure, it is a pressure required to bring about liquefaction at a critical temperature. So what do you mean by this so-called let's unlock some difficulty with the term liquefaction. So, meaning to say, liquefaction is a phenomenon in which the strength and stiffness of a soil is reduced by an earthquake shaking. Okay, earthquake shaking or other rapid loading. Liquefaction and related phenomena have been responsible for tremendous amount of damage in historical earthquakes around the world. So, what are the examples of liquefaction? For example, the Alaska earthquake in 1964 that explains what is the process of liquefaction. Okay. So it is basically occurs when a cohesionless, saturated or partially saturated soil substantially loses strength and stiffness. So it responds to an applied stress. So that will serve while why the earthquake, or why there is a so-called shaking during an earthquake or the other sudden change in a stress condition, because of the liquefaction. Okay, so meaning to say there is so-called critical pressure in that situation or in that stage. Next, the greater the intermolecular attractive forces, the more readily gases liquefy higher critical temperature. That is actually constant, and that is true. Cannot liquefy a gas by applying pressure if a gas is above critical temperature. That is actually correct. So this is basically explain how can we differentiate critical temperature and pressure, or how can a liquid or a gas or either a solid can be liquefied in either the temperature or in the pressure. So now let's go on the phases of the diagrams. So when we say phases of the diagrams, these states of matter exhibit by substance under different temperature and pressure can be summarized graphically in a phase diagram. So since we've already discussed the phases changes, so let's undergo now, or let's plot it on the diagram. And by plotting it, of course, we will be using phases of diagram. So this will involve curves, curves with the different states of matter like liquid, solid, and gases. So vapor pressure curve is also in here. So it explains the three important curves. So first we have vapor pressure curve of liquid. It shows the equilibrium of liquid and gas phases normal boiling point. So this normal boiling point explains the point on the curve where pressure at 1 atm. Okay? Okay. ATM, or it is called as atmospheric of pressure, right? Okay. So it is actually produced by atmospheric pressure, but when we say ATM, it is automated teller machine. So it's actually a unit. Okay, so aside from that vapor pressure curve of liquid, we also have variation in vapor pressure of solid at its sublimes at the different temperature, and change and melting point of solid with increasing pressure. So these are the three important curves in the phases of the diagram. So since we've already know what are those curves, that is very, very important in the phases of diagram, let's proceed on the structure of solid. So here we've already discussed it somehow in our first discussion, kasi I've already introduced to you the amorphous solid and the crystalline solid. So crystalline can be presented by its unit cell, which the smallest analytical unit that when stuck together produce the characteristic of three-dimensional. While amorphous solid can be characterized also of a solid, one of the solids. So not only crystalline solid but also a amorphous solid. So let's start with crystalline solid. Solid whose atoms, ions, or molecules are ordered in well-defined arrangement. So meaning to say, the example of it is flat surface or faces that make definite angles. Regular shapes, that is pertaining to crystalline solid. While amorphous solid, whose particles have no orderly structure. So that is the differences between crystalline and amorphous. Why? Because crystalline is pertaining to define or arrangement of a structure, while amorphous solid has no defined arrangement, or it is no orderly structure. Lack well-defined faces and shape, mixtures of molecules. So that is amorphous solid. Okay, so let's go now on the key takeaways or key points of this discussion. So I will be not reading this one. You will be the one to read this one because it is somehow a summarization. Aside from that, I also prepare a table that summarizes all the specific importance of differences between solid, liquid, and gas. So these are from its molecular representation to interparticle attraction to expansion and of course volume and shape. You can eventually know the differences of the three states here in the table. So yes, so that's it. This is aside from the key takeaways or the key points of the discussion, I also have a summarization or the conclusion of the physical properties of matter. So here. So I explain it or I gave it in a simplest way for you to know or for you to eventually understand it well. So if you have a question clarification, you can leave it in our GC and this will serve as your coverage in the examination. God bless and take your exam seriously. Thank you very much and have a nice day.